This is Unit 1, Lesson 11. Will Marty get back to the future? Today we're going to be discussing normal distribution calculations using the z-score chart and using the calculator. All right. Okay, so the first thing to do that you had to do is it asked you to label all appropriate values on the normal distribution model. I'm going to tell you on the test, I'm going to highlight in here what you'll absolutely need for a test. So the first thing you absolutely need is you need to label your normal model, which is this up here. The N stands for that's a normal model. The first number 80 stands for that's the mean, and the second number is the standard deviation, 7.7. This is only if they ask you to label all of them. If it doesn't tell you to label all of them, you don't need this part, and you'll just do a truncated part, and I'll share that later. But you definitely need to put the N. You definitely need to put the 68%, the 95% with 2 standard deviations, and the 997% is 3 standard deviations. The next thing you need to do is make sure you label everything down here. And one thing that's not included on here is that we need to explain what all these things are, which let's add that. So this is DeLorean speeds. So we're going to write DeLorean speeds as the title. And then list down here, let's go ahead and put some sort of a label down here. So I would put a label here, and let's put speeds in miles per hour. So making sure I have everything. And that would be the total. So if you notice, let me just kind of go through here and show you the speeds and the DeLorean speed. So you can see all the totals as far as what would be on the test. The labels, the title, the label here, all the tick marks on the bottom, and the 68, 95, 997. Okay, so at this point, number 2, 2, 3, and 4, you're just adding up the little areas. And I showed you on the last lesson of how to find these little areas. But if you're not sure, all we're doing is just taking this as a math portion. For instance, if this is 68% from the middle here that I have highlighted, then this blue part here is going to be 68 subtracted from 100, which is 32, divided by 2, and those are both going to be 16. And then we're just going to find each individual portion from there. I mean, as I said, just a math portion. The same thing for 95. This green part is going to be 5, and then divided by 2 would be 2.5. And then let's go ahead and make a purple part, right? 997, this outside part here would be 0.15. So you can see just from saying, okay, to be able to find 13.5, for instance, the way we're doing that is we're taking the 95. We're taking the 95 here, the 95, which is spans from 2 standard deviations right here, and we're subtracting the 68. And then we take 95 minus the 68, we get 27. And divide it by 2 because I have this portion here. And I have this a portion here. So all here. Okay, so those 2 portions. And those, so 27 divided by 2 is 13.5. So similarly, that's how I got the rest of these values. And that's how we got 2, 3, and 4, because we just looked up the values and just added them up. So greater than 87.7, I just said, 13.5, 2.35, and 0.15, and that's it. Okay, for number 5, though, you can't do that because it doesn't land perfectly on a standard deviation. So we have to go use our table to be able to find that. So we are going to be able to find speeds that are less than 68.45, which is smack dab in the middle. So if I were to draw it, it would look like this. It's here, my 80, and then I have the next standard deviation is going to be 72.3, and then this one is 64.6, and there I have 68.45, which is right here. And these here, these guys, those are going to be less than. So for less than, these guys, I don't know because I don't have anything that has my perfect, standard deviations here, so I have to find a z-score. So to do a z-score, let's go ahead and I'm going to show you on a chart first, and then I'm going to show you the calculator. Okay, so let's look at a chart up from here. Sorry. Okay, so for the chart, this is our z-score chart. These are located, you can either, all I did to Google, I just Googled AP Stats Formula Chart, and you can see it's on AP Central. You can also, it's also in the back of your book. You can also see it you can, in the classroom, you can take a picture of it as well. The z-score chart, if you notice, is shaded from the left, and it tells you that the table is all the probabilities to the left of z. All right, so for this one here, you can see the z-scores are down, so negative 3.4, but negative 3.40 is this first value, oh, sorry about that, of 0.03. For the next value would be negative 3.4. For a z-score of negative 3.41, the value would be 0.003. And what are these values? These are the percentages under the curve. This is the percentage under the curve. So if I were to look at a z-score of negative, let's go to any of them here, of negative 3.4, it would be negative, that means there's about 0.003 or a 0.03% of the curve is shaded. So let's look for a z-score. Remember, these values are the percentage under the curve that's shaded. So let's look for a z-score of negative 4.5. So negative 4 is here. The first value is 0, 1, 2, 3, 4, 5. And if you go all the way to the top, you'll see that's 0.5. There you go. So I'm looking for, lost my place here, negative 4.5. So I think I haven't lost my place. Let me see. 0, 1, 2, 3, 4, 5. There we go. So 0.3264, that means 32%, about 32.64% of the curve is shaded at the z-score value of negative 4.45, sorry. All right, so if I want to look a positive z-score, look up the z-score of 1.7. I have to go to the other one. 1.7, you look at 1.7 is way out here. There you go, so the very last one there, and that is 85.77, this one right here, right in the middle. Because 85.77 lines up as 1.7. So I'm going to show you then the different aspects of the z-scores. So what is the z-score of, let's look at 1, for instance. Let's just look at 1 because it's right here. 1 is 0.84. So 0.84. And now let's look at what it's going to be for negative 1. And I'm going to tell you, I'm going to just give a wild guess. And I think the z-score for negative 1 is going to be 0.187. So let's see. Remember, that's 0.84. So let's go look at what negative 1 would be. So let's go to negative 1. And my guess, remember, was 0.1587. So let's go to negative 1. Oh, there it is, 0.1587. How do I know that? Well, would you please add 0.1587 plus, let's go back to what 1 was, 0.8413. Well, that equals 1. So every z-score plus its negative z-score is going to equal 100% because the curves are symmetric. Okay, if I told you, and so if I said, okay, what is my z-score? Let's go opposite. What's my z-score of 30%? So you're going to go find on the chart as close to 30% as you can. 30% is about here, right there. So 30% is about there. You might have been able to find something a little closer, but this is pretty good, the third one out. So this is negative 0.50 is the first one, 0.1 is the second, 0.2 is the next one. So it's pretty close to 0.3015. So my z-score is the corresponding negative 0.52, because if I go all the way to the top, you're going to see that too. And that is my z-score. All right, let's go back to the problem then. if you notice, it says what percentage of the runs will give the DeLorean a speed of less than 68.45. And I just discussed that this here, if I add the area here, let me get us here. If I add the area in this little area, plus half of their area there, I get 9.25. However, because this area here is not a rectangle, you can see this area here, that would be incorrect for me to just divide it by 2, because if I had this, if it was shaped like this, yes, I would agree that I could divide it by 2. Oh, actually, I'm sorry. There we go. If I had it like that, if that was the shape, 100%, I could divide it by 2, no big deal, it's cut in half. But as you can see, the problem is I can't cut it in half, so I am going to use z-scores. So let's find the z-score. Remember, the z-score is the observed minus mean divided by standard deviation. And so my observed value was 68.45 minus 80, because that was the mean given to me, divided by 7.7, and I get negative 1.5. So then we're going to go to the table. Okay, negative 1.5, as you can see, is right here at 0.068. So that's a z-score for negative 1.5. And as I indicated here already, that is 0.068, which is 6.8%, 6.68%. All right, so the last thing I want to make sure you do is, with all of these, in order for the test, I just want to mark for you what is going to be required for a test. So for a test, there's 4 things that you need to include. First of all, the first thing you're going to include is going to be a picture. So for this one, I'm going to do number 5's picture. This is number 5. I would just do this here. And it says this, remember the speed, the average speed was, what it gave me to was 80. And this asked for less than 68.45. So I'm going to I know that that's going to be a little bit more than 1 standard deviation away. Shade, that's the what percentage. So that's first is a picture. Secondly, I'm going to write a probability statement. So I'm looking for the probability that X is less than 68.45. But because I don't know it, I'm not able to just go right here on a standard deviation that's right perfect. I have to convert it to a z-score. So a z-score is going to be the probability that the z-score is less than 68.45 observed minus mean divided by standard deviation. And I don't know what that is. So the third step is I'm going to use my table. And if I use my table, I continue and I say that's the probability of, which I just found when I did the math, as less than negative 1.5. And that is equal to, as we found, 0.068. And the fourth step is going to be about 6.7% chance or probability that the DeLorean will be less than 68.45 miles per hour. So that's how you do it if you're using the chart. I do want to show you how to do it on the calculator. So on the calculator, you would do the same thing in the beginning. The first step would still be to do this. The second step would still be to do this. What changes is the third step. So for the third step, I'm just going to go ahead and put it in black, and I'll put it here. This is, oh, sorry. There we go. So the third step, this is if I use a calculator. So I'm still going to write the probability statement, and I'm still going to write the z-score equation because that gives me my observed, my mean, and my standard deviation. But I do not have to write this step if I use a calculator. If I use a calculator, I'm going to actually use the calculation of normal CDF. My lower bound, which is my left bound, is going to be the furthest left that this is, which is negative infinity, but I can't put negative infinity on my calculator, so I have to put negative 999. On here, you could definitely put negative infinity, either way. The upper bound is where the rightmost part that the shading stops, which is 68.45. The mean is 80, and the standard deviation is 7.7. And then I would get, on the calculator, which I'm going to show you here in a moment, 0.068, and then number 4, I still would write this. Let's go ahead and look at the calculator. So on the calculator, you're going to go to Menu, Probability, Distributions, Normal CDF. Lower bound, negative infinity. Upper bound is, what do we say? Sorry, 68.45. Mean is 80. And standard deviation is 7.7. And you can see I got the same thing, 0.0668. And you see the normal CDF, there's right here. You can't just write it out without making sure you label it, so just do it this way. All right. So let's go ahead and look at this here. What percentage will DeLorean give you? Now, on all of these, step 1, it is done with the model. It's done. Step 2, the probability statement's not given. So I'm going to write the probability statement. So this is step 1 is given. It's already done. What's the percentage that the DeLorean will give if it's greater than 85? So greater than 85 is going to be probability that Z is greater than 85 minus 80 over 7.7, and I don't know what that is. The third step is going to go ahead, and this is actually finding the Z-score. So if you're doing the Z-score, it gets 0.65. So if you're doing Z-score, it'd be probability that Z is greater than 0.65. And we don't know what that's going to be. If I'm using the calculator, I'm going to go to, if I'm using the calculator, remember, I'm just going to cross this off just so you see. If I'm using the calculator, I don't need that. It's not wrong for you to put it, but you don't need it. Instead, I'll put normal CDF. Lower bound is going to be, for this one, is 85. Upper bound, infinity. Mean, 80, and standard deviation is 7.7. And I'm going to get the same thing, and I'm going to get 25.78%. Now, of course, on the Z-score chart, I have to go then look in table A is the Z-score chart, and I have to look at the Z-score of 0.65, and I'm going to get the same thing. I'm going to get about 25.78%. And then that's the third step, right? And then the last step is going to be step 4. And step 4 is going to be about 25.78% of the speeds of the DeLorean are greater than or equal to 85 miles per hour. Number 7, what percentage of the run between 70 and 95? Okay, so for between 70 and 95, this first step, draw a picture. Second step, probability statement. With the second step, the probability statement is going to be, I'm just going to write it over here, probability that 70 is between, that I'm going to be between 70 and 95, and that's equal to 70 minus 80 over 7.7 is less than Z is less than 95 minus 80 over 7.7. So this is going to be sandwiched. I ran out of room, so I have it here. And if I'm doing the Z-score by hand, I have to actually find each one. So if I did the Z-score, I would say this is equal to the probability that negative 1.3 is less than Z is less than 1.595, excuse me. And then what I would have to do is look at my Z-score table, look at 1.95, and find that it's 0.97%. And I'd look at negative 1.3 and see that that is going to be 0.0968. and then I'm going to subtract them and get 87.6%. I could do that, which that's of course my step 3. Or my alternative step 3, what I've shown you guys, is to go ahead and do the calculator. So step 3 could be normal CDF, lower bound 70, upper bound 95. Mean 80, standard deviation 7.7. And you're going to get step 4, the same thing, 87.7%. And you're going to write a quick sentence, and you're going to say the percentage of runs that give the DeLorean a speed between 70 and 95 is 87.76%. For this one, it's the opposite. This is top 15%. So you're going to, I'm going to go ahead and write step 1. You have the picture. Step 2, you're going to have the probability statement. Probability that X is greater than, now I don't know this. You see that's a question mark, so I'm going to put Y is equal to the probability that Z is greater than Y minus 80 over 7.7, because I don't know the value. And we do know that the probability equals 0.2. Oh, sorry, not 0.2, 0.15. All right, so step 3, they're going to, for for z-scores, you're going to look up, since this is 15%, we know, this here, remember, is 85%. And your z-score chart, remember, shades from the left. So you're going to get a z-score of 85%. So my z-score of 85%, if you look it up, it's going to be 1.04, because if you look up z-score, you look up about 85%, and you'll look 1.04, and you'll look on your z-score chart, and you'll see that's what indeed I have. And it's something close to 85%. You're not going to get it exact, because the z-score chart doesn't have 0.85, and that's it. All right, so then what you would do from there is you'd have 1.04 is equal to observed minus mean divided by standard deviation, and then you would solve this equation, and Y would be 88 miles per hour. If you did, this is step 3, of course. If you did the alternative step 3, which I'm going to show you in green again, you would do inverse norm. And the inverse norm gives you area, mean, and standard deviation of your choice. Area is going to be 0.85 because it is 85% to the left of your value that you're looking for. The mean is 80 and the standard deviation is 7.7, and it also gives you 88 miles per hour. And then step 4 would be the conclusion, where you say Marty wants his last run to be the top 15%, which is a minimum speed of 88 miles per hour. Okay, so remember, this is how to find with table A. Remember that your value is a percent, and the z-score is your value minus your mean divided by standard deviation. And then you go to find your z-score percentage, you go to table A, and the percentage is to the left. And remember, if I have 2.4, and then I have 0.01, or 0.00, 0.01, 0.02, 0.03, so forth and so on. And let's say I want that one, I would go here, and that would be my answer. So this would be z-score of 2.43, and this would be the percentage corresponding to the z-score of 2.43. Remember the proportion to find in the center of table A, which is the z-score table, and then you're going to match your percentage to your z-score as best as possible, and then plug in the numbers to solve, and this is how we found our inverse norm. This one here is inverse norm if you use the calculator, and this one here is normal CDF if you use your calculator. All right, what percent of adult elephants produce at least 300 pounds of waste in a day? So you have your model. Now notice if it's a new problem, you need to make sure you put N25021. On these little ones, I didn't, because we did originally in our original model. So since this is a new model, I'm going to put my normal model, I put the mean, I put the standard deviation, or excuse me, I have put the value, and I put the area that I'm either trying to find or I already know when I'm trying to find a value. Okay, so the standard deviation is 21. I also like to include 21 plus 250 is 271, plus another 21 is going to be 292. So this is 271, 292, just so you can see, plus another 21, and that's going to be over here now, my third standard deviation. So I know that it's going to be between 2 and 3 standard deviations is what that percentage is going to be. And remember, 2 standard deviations is 95%, so that's 2.5%. And 95%, 99%, excuse me, is 99.7%. And that outside is 0.15%. So my answer's got to be between 0.15 and 2.15 and 2.5%. So the way I'm going to do it is if I did remember, step 1 is my picture. Step 2 is my probability statement that x is greater than 300. But that's the same as the probability that z is greater than right here. Here's my probability for my z. Should I do this? Oops. And then from there, if I'm using the z-score table, I'm going to continue to solve there and then get my table. Now look at this. I got 0.993, which you can see this is definitely not 99%. So it's 1 minus 99% because this here is where that 99.13% is. But I want the shaded part, which is that upper part, which ends up being 0.87%. If I did this with my calculator, then I would, instead of this step here, I would skip and I would do normal CDF. Lower bound 300, upper bound infinity, or 9999. Mean is 250, and standard deviation is 21. My conclusion, of course, step 4 would be about 0.87% of adult elephants produce at least 300 pounds of waste a day. A zoo agreement with the local farmers. They sell daily on the elephant, and so I am looking for the 10th percentile. The 10th percentile, as you can see, the drawing here is down here. So step 1, I've drawn a picture. So look, I've got the normal model labeled, I've got the mean labeled, then I've got my percentage labeled with, okay, I'm just going to call this y. Okay, next I'm going to write my probability statement. So my probability statement is going to be the probability that x is less than a y, and that's the probability that y minus 250 over 21 is equal to 0.1. Oops, I should have pushed this over a little bit. Try that again. The probability that z is less than y minus 250 over 21. And that's equal to 0.1, 10%. So at this point, you can see you're going to find the z-score for 10. And that is actually equal to negative 1.28. And you find that by looking at your chart. And then you set this equal to the equation that I have here. And then solve. By multiplying both sides by 21 and adding 250. All right, if you did this in the calculator, it would be inverse norm. And your area is going to be 0.1. The mean is going to be 250. And the standard deviation is 21. Okay, and then the final step is to say, to just how much money. So just, I would say here, which is my x is 223.12, and remember that's $5 a pound. So I would say about $1,115.60 is enough money to make this zoo selling a waste that day or less. So it's anything less than that number is a waste because we have to have 10%. Okay, that's it for this. I hope that helped you, and you guys have a wonderful day.